Signori, buongiorno, ladies and gentlemen, good morning. Thank you, and a special thank to Nanni Doglieto and Sergio Ferri to inviting me to present to this distinguished audience today, even because I have a pleasure to witness with my personal history what is part of the history of the evolution of inguinal hernia surgery. In front of me, one of the moderators today actually was a senior resident who taught me how to perform a Bassini technique at least 30 years ago, and one of the director of this program, Parvis Hamid, was the one who 25 years ago, when I was a visitor in Los Angeles, taught me how to do my first Liechtenstein operation. As you see here, history of hernia operation has walked together with development of new prosthetic materials. And just when a synthetic new filament of carbon polymer that we today call Marlex, but this polypropylene, came out, we had the availability of a new method that received overwhelming evidence of mesh superiority after the first reports by Liechtenstein. As you see here, with tension-free repair, the end point in hernia repair was not oldly and not permanently recurrence. These are the number of published items on recurrence after hernia operation, but as you see, published reports on pain were growing after the fall down of the recurrence rate. And the ratio between reports on pain and reports on recurrence is totally reversed today because pain is the main issue. Well, 11% of patients, according to this important review today, complain of some discomfort or real pain or real neuropathic pain after a prosthetic repair. So there is something to do in between pain and mesh. And who examined the cause of pain found out at least 4 important points that are in relation with chronic pain after hernia operation, and the composition of the mesh is one of them. The baseline of meshes, so I will not talk about history of meshes, but the baseline, late 70s, is Marlex. It's polypropylene, an heavyweight polymer that is knitted in a mesh, and it responded almost ideally to the possible characteristic of an ideal prosthesis that were ruled out by Liechtenstein and his collaborators and Parvis Hamid this year. But today, these that seem to us to be fixed points are not that fixed anymore. For example, permanence is not an absolute dogma. If we today hear some people repairing with glue and opposing their meshes with glue, or if this kind of products use absorbable hooks to adhere to human tissues and then are late reabsorbed. Inertness is not a total dogma anymore, and part of the mesh now can be composed of absorbable material, not only for the benefit of absorption, but with the intention to lead the new ingrowth of tissues. And what was considered, this is the most important thing, what was considered to be one of the special characteristics of a mesh, the so-called fibrinose fixation and host tissue incorporation, is the problem related with pain. As you can see here, the fibers of polypropylene, in that case, with their granuloma reaction around them, are involving some nervous fibers, and the red line stresses a point in which the nervous sheath is eroded by a polypropylene mesh, explaining why the mesh can be involved in the termination of postoperative pain. So what can be done to avoid this? What has the industry produced to help us in controlling this new issue of pain? The first thing that came out is that new lightweighted polypropylene mesh can control pain in a better way. This review is comparing in two papers that have been studying the different behaviors related to pain of normal weighted and light weighted meshes, and you can see here that there is a significant difference. So what is old and heavyweight what is today monofilamented in a larger pore and less material, what can be the next generation. Of course, you can compare weights and pore size, and you see that the difference is relevant if you look at the structure and think in a macro dimension. You understand that the new meshes are very different from the meshes that we started out 30 years ago. Is this really an advantage? Well, compared to stiffness, that is part of the postoperative discomfort, the superiority, according to this important report, is rather evident. And burst load can be a disadvantage. Of course, a lighter mesh with larger pore size can burst easily. But if you consider what is the burst load of a native fascia, anyway, new meshes are much more strong compared to native fascia. So it is not really a problem that these meshes are not extremely resistant like their relatives, the older relatives. What is interesting is that in this experimental paper, some meshes have been implanted and removed 5 months after. And heavyweight and midweight meshes don't decrease their stiffness and their host tissue reaction, their incorporation. Lightweight meshes in months change, and they are less stiff and less reactive. These values are not so low to create any problem as regards the burst load of these meshes, but stiffness decreases, and this can be part of the better behavior of this lighter mesh with regards to postoperative pain.